Epik Mellon podcast, conversations with the real humans behind broadband networks, cybersecurity, and the future of communications. Brought to you by QA Cafe. Hello, everyone, and welcome to yet another episode of the Epik Mellon podcast. I'm not even going to give this one a number because I don't really know, which is a great feeling because I've had enough that I don't know anymore. I'm here with Wojciech from Icotera, and we worked together indirectly for a while, but I actually met him in person back in March, and I thought you would make an excellent candidate for having a radio voice and being on here and talking about
so I
stuff
do
that's
have
going
a
on.
radio voice. I was wondering what is your criteria. It's
It
a
is.
radio.
You have to at least. I have to at least find you mildly entertaining. So.
Oh, I wonder when was that. But okay, I guess I'm flattered.
So Icotera is a company that makes networking devices. Most significantly to me, broadband CPE and Wi-Fi products. And I know I've talked to a couple of other people from a couple other companies who do similar things, but obviously that's where our wheelhouse is. So it's going to be interesting to get your story. What we try to do here is humanize us weirdos that are behind broadband networking. So.
Yeah, I'm definitely.
Don't you know we make the internet work? As always, Epik Mellon Podcast is brought to you by my employers at QA Cafe, and therefore the views expressed by myself and Wojciech do not reflect those of QA Cafe or its ownership, and I imagine the same goes for you with Icotera. Yes. We those are our own opinions. Fiery as they may be.
Weird.
It's being brought to you by QA Cafe. We have 4 great products at QA Cafe, some of which Wojciech is intimately familiar with. That is CD Router, the industry standard test platform for broadband gateways and Wi-Fi devices with thousands of fully automated test cases that make your life a whole lot easier in delivering great products. The second on that side of things is Passport, which is our test solution for end devices, such as smart home devices, set-top boxes, and other things that use those packets rather than pushing them around. And it's as easy as selecting tests, hitting go, and making sure that you find problems before they end up as a bad review on Amazon. And then on the network analysis side of things, because we look at packets a whole lot, QA Cafe makes CloudShark, which helps you work together with other people on difficult problems while looking at packet captures, and Packet Viewer, which lets you take that power and put it into your own cloud-managed networking or cybersecurity product. To find more about all these things, you can visit us at www.qacafe.com. All right. Yeah. So, like I said, I just want to it's entertaining to me, right, to find the people who have decided to do this in their lives and why, and whether it was on purpose, whether it was by accident. So I do want to hear your story about that. Like, have you always intended to get into networking, or was it another sort of, well, here we are?
Well, I guess I would be an exception because the answer is yes. I was actually I knew that I'm going to do networking for my career for a very long time right now. I actually attended a university when this was my main specialization. Cool. Yeah. And before
that's cool because there's not a lot of programs out there that are actually focused on it, like especially at universities, right? It's like you're either doing computer science or you're doing electrical engineering, and maybe you get some networking courses at the same time, but
Well, at least on paper, the specialization was networking. I think it was actually named networking. Obviously, we did a lot of other stuff like programming, project management, and stuff like that. But networking was at least in the name, so I had a chance to learn something. But even before that, I knew that I was going to do it. Right, since the first time I got a dial-up modem, remember the sounds, and I was there. I liked that. I have no idea how it works back then. But it was super cool, and it was extremely expensive. So the whole story started in my block of flats with some neighbors. Actually, I was a kid back then, like 12 or something. when we started, to gang up and share the internet connection, which now back then was, an endeavor. we, I managed to install the Ethernet cables, the UTP cables, UTP, not the coaxial kinds,
Yeah, yeah.
with a screwdriver, because we didn't have like those proper tools for back then. And we didn't even knew that they existed. We just had
Right.
the cable and the plug, and we did it. It was fun.
So was that I mean, you were dialing into, I mean, the web existed at least, right? So, or were you dialing into like bulletin board services and that kind of thing?
No, when I started this dial-up thingy, dial-up modems, that was a bit before. IRC existed already, right? So that was
Okay, okay, okay. Yeah, yeah, yeah.
the main
Yeah.
thing back then. If any web pages were actually existing, I don't know, but it very quickly moved into file sharing and stuff like that. It was a big thing. Yeah.
Right. Right,
But
right.
it took a while. It took a while, and when we started this local ISP of ours, then I think we already moved up to ISDN connection or something.
Right, right, right.
Yeah, so
Oh,
I'm
so
not sure because
you literally did start an ISP for your flatmates and then it grew on a,
I was a part of it. I was not the main guy there,
yeah.
but I was since I was 12 or I don't know, maybe 15 when we did this Ethernet installation. I was helping like a adult person do that, but then I quickly took over. Uh, I branched out because I got my first DSL connection, and that
Nice.
was cool. I built my own router from a refurbished server, a dual CPU Intel Pro something. Yeah, I had to compile the kernel for that. I have no idea how I did it back then. I have no idea how long it was. And you had to set up the IP tables, with Masquerade and stuff.
Oh
And
man, yeah.
that
Yeah.
wasn't common knowledge back then.
No, no, no. And I really appreciate that though, because it's like, even in my own journey, it's like necessity breeds curiosity, right? So like, it's like eventually you were trying to do that not just because it was cool, but because you were trying to do something, right? And like, I
I was
remember,
trying to save money on
playing
the internet. That was
playing
the
early
only.
video games on Windows, where you had to like dynamically allocate memory and stuff like that. And I wouldn't know the stuff that I had known if I wasn't like, okay, well, I guess I got to figure this out, right?
Yeah,
Playing Wing Commander several hours later.
Win Commander.
Oh yeah, yeah, the original, which you can still play, but the engines that emulate it have to like really, really, really tone down your CPU because it doesn't control itself. So you try to play it, and it's basically
Yeah,
everything's
yeah.
moving really fast, and then
Yeah, I'm not really into retro games, even though I was a big player back then. I still am, but somehow I found that playing the games already played is not as entertaining as
yeah.
I would
They don't
expect.
all translate. They don't all translate well into like modern sensibilities of what a good game is.
That's true.
So that's cool. That's cool. So you got bit by the networking bug early then. So where did it
Yep.
go from there?
Well, I guess I graduated the high school soon after, and then immediately I seek a university that has to do with internet. So I actually tried once and failed. That was actually around electronics, but it also had the telecommunications in the
Hmm,
title.
hmm.
Then I moved into IT with networking as specialization. I managed to have fun learning some of the stuff. I didn't learn that much, but at least I had something on my resume.
Right, right,
And then
right.
immediately after the university, I started working for this, our exciting new thing, which was called fiber. There was this company in my vicinity that was installing fiber. That was cool. Optical electronics. That was, something that I actually liked.
Right.
Even though it's not really protocol based, at least back then, the layer one stuff. So I started doing that, some installations, some measurements, stuff like that. And then something extremely weird happened. The company like merged with a group of Danish guys who wanted to sell fiber equipment, not just any fiber equipment, FTTH fiber equipment, and I just moved just naturally. So you can say that I'm still in my first job.
Yeah, yeah, yeah.
Never changed my
What
employer.
Which is honestly not too unusual. I actually like only I know a few people who have moved through like 20 companies, but it was all mergers. So like even Tim Spetz, who is one of my partners in crime and making, tier 69, tier 369 and stuff. We joke because he's had like 20 different badges, but he's always had the same job. Right.
Yeah, for most of my career, I had the same boss actually.
Yeah.
That's kind of weird.
That's kind of weird, isn't
Yeah.
it? No, I actually appreciate that though, because I feel like I don't know, I feel like there was a trend for a while on both sides to have either people be very dispensable or on the other side where you're like, oh, I'm a knowledge worker and I'm only here to get enough out of you company until I decide to move on to something
Well,
else, right?
I feel like I'm still in that stage. The only problem is that new knowledge is thrown at me every day. So
Oh yeah,
learn
so
that
you never
stuff.
have to go anywhere. Yeah,
I haven't have enough yet, right? So
yeah,
I
yeah.
still have knowledge to get. That's the beauty of it.
That's cool. That's cool. And stuff has changed, right? So
Oh yeah.
you've been doing CPE for a pretty long time, and that that has changed radically even in an extremely short period of time.
Oh yeah.
Yeah.
Yeah, and not only the technology has changed, my specialization has changed. We started with generic networking, and I specialized a bit in the optical part of it because I knew how it works. Optical Ethernet, not PON. For a very long time, we didn't do any PON, so
Right.
just Ethernet. Ethernet is easy. You don't really have to understand the protocol.
Did
You
you
just need
hear
to.
that, everyone?
Yeah, I mean, I thought that for a very long time until we started experiencing some issues with flow control or green Ethernet or something like that. But till then, nobody really thought about
Yeah.
Ethernet. Like, it was actually, if you recall, at the beginning of 802.11, uh, Wi-Fi was a bit like that.
Well,
Nobody
that's
thought
what's
about.
so weird, right? Because effectively what happened, right, is you have like Wi-Fi was back to the days of Ethernet, which was meant to control a contested medium, right?
Yeah,
And
it,
on the wired side, what they said was like, "Wow, this sucks. Let's make it so it's not a contested medium anymore." Right? But Wi-Fi is still suffering suffering from that to this very day. And everything we do for Wi-Fi is to get around those basic problems that Ethernet got around by not being Ethernet.
yeah. Actually, I'm a huge fan of Wi-Fi. I guess you know that, and
Oh yeah.
it's 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 not because I think that there is nothing else. I just genuinely think that technology is great, and the best advantage of Wi-Fi is actually also its biggest weakness is these congestion algorithms,
Right.
right? Why do Wi-Fi is such a success? It's not because it's centrally controlled, because all the mobile technologies are centrally controlled. They're also a huge success, but they're also extremely expensive. Wi-Fi is
Yeah.
a success because it's affordable, and it is affordable because of the congestion algorithms that allow Wi-Fi to work in unlicensed space. And Wi-Fi
Right. Right.
is the algorithm behind Wi-Fi medium control is decentralized, and it still works.
Yeah.
It just works, and in most of
Right.
the cases, it works great. If Wi-Fi is bad, which rarely ever happens nowadays, at least for not for me, is because there's something outside of Wi-Fi that is not playing nicely
Right.
in
Right.
most cases.
Right.
Right?
Right. And it's not necessarily that Wi-Fi. I beat up on I beat up on Wi-Fi a lot on the show, but only as a joke, right? Because I understand why how wildly successful it is and why. But it's people have bad experiences with it because it is so ubiquitous and it was never intended for all of the networking use cases that we use it for today. And that's okay.
It was never intended. That is true. Yeah, as
Right.
you said in your other podcast, it's Wi-Fi is the victim of its own success.
It is, you know, it's like, okay, this is a great job. You're doing a great job managing a contested medium and making sure that everything is decentralized and interoperable, and that's your power. Okay, now I need you to do Zoom calls constantly all day long.
Yeah, VR,
Yep,
online gaming. That was
yep.
never intended. But I'm I would say, I would guess, or maybe even a wager that if Wi-Fi was not intended for it, and somebody would design a protocol that is intended for it, it would be very similar to
It
Wi-Fi.
probably be very similar. So, how to tell me about that journey? Like, how did if 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 you've been starting with fiber this whole time and then were thrust into the Wi-Fi world and loving it, like, did that happen over the course of time, or was it just because of the products you were working on, or?
It has to do with the company I work for. Like when we
Mhm.
started, we were like four people, right? So of course I had to do everything. Or around, started with testing basic software. Then when we got the first customer, I started supporting the customers. Then when we grew bigger, I led the support team, and when we grew bigger, it became obvious that we need people that will actually formalize requirements and do some high level design. And then I had some colleagues that could offload me in some other matters. So I thought that I can focus on something that nobody else knew anything about,
Right.
and that was Wi-Fi. Nobody knew anything about Wi-Fi back then. It's still like a kind of a secret knowledge about the Wi-Fi protocol, how it
It
works.
is.
I am not sure why.
It's kind of black magic, right? Like,
It is, even though it's extremely simple. I can explain Wi-Fi in like 2 slides. Walkie-talkie. That's
yeah,
it. That's how
right,
Wi-Fi
right.
works, right? Uh, so yeah, I started to dig deeper. I like what I saw, what I read. I found that it actually understanding the protocol, like any protocol, makes my life as maybe customer support or debug specialist much easier. Right? It's so much easier to debug problems when you know what is expected.
It
Uh,
really is. Yeah.
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 So that's how I kind of transitioned into the existing role, which is I think it's SME, subject matter expert. I'm, for lack of a better word, I'm just the guy who knows how stuff works.
That's the title of this episode now.
Okay,
The guy who knows. I like it.
a guy who knows how Wi-Fi works, or not only Wi-Fi. Actually, I'm used to for any other protocol. If something is a bit not obvious, then Wojciech, go and explain us how it works.
Yeah. Yeah.
And
No, and it really
if
is
you
kind of
master
like unique. I don't want to say it's because I'm sure there's plenty of other fields that are like this, but I really enjoy networking technology for that reason, right? Where it is sort of it's not really a puzzle. It's like a language, right? You're learning to understand what what the interfaces are saying, right?
yeah.
And if they understand each other, right? You're like a little anthropologist translating us.
Well, once you understand layer three, right,
Mhm.
then IPv4 versus IPv6 doesn't really make too much difference. You know why is it for? When you understand the HCP, then I don't know IPv6 net neighbor solicitation and the IPv6 suddenly makes sense because you understand why the whys, right? The whys are the most
Right,
important. If you know the
right,
whys, then the hows are just a matter of reading the standard, the white paper, or even watching a YouTube video, and
right.
then practicing a bit, and then So if you understand like 6, 7 protocols in the internet, then learning the 8 or 9 is easy. It's like with languages. It's
It's
exactly the
just like
same.
languages, isn't it? Yeah.
Yeah, it's just
Yeah.
another language. Come on,
Maybe
easy.
that is why I like it so much because I do love languages.
Oh, okay.
Yeah. I'm not very good at speaking other languages, but I do love kind of
Oh,
picking them
okay.
apart,
Then we
especially.
have the same thing. No, I learned English, but that's it. I try
Yeah.
to learn German and Czech, because they are neighbors of my home country, but I failed miserably.
Yeah, right. It's not
Easier.
easy. The thing that I learned is that, and I guess this is kind of the 80/20 rule with protocols too, where it's like you can spend 20% of your time becoming 80% of an expert on a
Mm.
given topic, and then the rest of your time is like getting the rest of that small piece of becoming an expert, right? And it is kind of like that with networking technologies, right? So it's like you can dive in and really, 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 really understand one thing really well, but for the most part, like you're going to have a better time knowing how to do all this stuff if you just kind of,
No,
take a broad brush.
I just thought of something. One of the main reasons I'm actually became so I think so good when understanding other protocols like IP, this TCP, like QoS, buffering, this kind of stuff, is because I was troubleshooting Wi-Fi issues. And when there's something wrong, when the TCP throughput is not as expected, when the speed test is a little below the expected, everybody says, "Oh, Wi-Fi issue, Wojciech, figure it out." And then I'm coming in. I spend like 10 seconds looking at the metrics and nope, that's not a Wi-Fi issue. But let's figure out what it is. And then it's either a TCP issue, a buffering issue, latency issue, a packet, somewhere
DNS,
flow
DNS, DNS,
control.
DNS, DNS.
Well, with DNS, it's easy. It just doesn't work. I mean, you don't have a connection. But if you're getting the throughput just below the expectations, then it becomes difficult. And
Right.
I
That's
recently
interesting
learned tons
because
about
people
TCP.
do blame it on Wi-Fi a lot, right?
No, I have no idea why. Wi-Fi
Yeah.
just works. Come on. And I mean, of course, sometimes there might be a buggy driver.
Yeah.
Happens, right? But then look at the MCS, look at the link speed, look at the wear time, and if all of those three checks up, then it's not Wi-Fi.
Well, it's
Yes.
in that I was going to touch on this a second ago because you were mentioning you know being once you understand the protocols and you know what to read, then you can kind of understand it. But interestingly enough, the problems with most protocols is from either people's lack of doing that or uh, the spec not being clear enough and people making weird choices that the spec writers, right, like me, and never intended, choices that we never intended people to make. And so does like is that what is generally happening where like there was a bad implementation because of interoperability problems that you usually see, or was it just, or is it more lower level than that? Um, and like, how does that come out in the wash? Like, oh, we often experience like I don't know a good way to put it, but it's like a mistake that one person made in like one piece of software when it comes to a networking stack that gets like it gets pushed down for years and years and years because everybody's using the same thing and it never got fixed and that kind of a thing.
Mm, honestly, I don't know. I'm not that deep in the code of
Hmm.
how the people are implementing specifications. I don't think that this is the case. That is because of poor specs. Usually, I find that if you actually are implementing a standard, then everything's fine. The problem starts when you're trying to figure out your own solution
Yeah.
and you're too bothered to look at the standard. It's way too big. The standard. Come on, it's
Yeah.
easy. Let's do it this way, right? That's usually what triggers some interop issues.
Right.
With performance issues, it's something else. It's low level drivers, and sometimes it's hardware, sometimes it's low level APIs that are not implemented yet, and your vendor did not share that
Right.
this is not implemented yet. It's more like that, right? But
Yeah.
if when it comes to interop, it's people ignoring standards. That's the problem, right? I think.
It's like I've seen a couple examples in the past where people have sort of chosen to do like in the early stages of a standard, people have sort of chosen to do that on purpose so that that stuff will only work with their stuff, right? Or will work a little bit better because they,
Oh,
you know, because they did something such that if they see themselves on the other side, then they can do their own proprietary
Yeah.
stuff, right?
No, we are doing not only routers and Wi-Fi, we are also doing ONTs nowadays, and uh, I think for the good, we're doing PON stuff, right? And
Right.
in PON world, I'm not engaged, and I'm very happy. I have a very smart guy who's doing that all the heavy lifting for me. But in PON world, that's a plague. I heard, like everybody's
Really?
doing some quirks in the MCI stack to make sure that stuff works better with their equipment, like the OLT vendors versus the ONT vendors, right? We are on the, we are small, we are only doing ONTs, so we have to play with whatever the OLT vendors are throwing at us, and even though they're pretending to follow standards and best practices, at least this is what I'm told, they're often on purpose doing what you said. They're just adding some quirks to make it more difficult for guys like us, but maybe that's an excuse. I don't know. I'm
That's extremely frustrating, especially because it's not to get on, the behavioral economics of it all, but like
yeah.
I've seen like the fiber industry is very competitive, so you can imagine that that sort of thing exists so that everybody will always have their secret sauce,
Yeah, but amazingly enough, it almost never happens in Wi-Fi.
Yeah,
Of course, those chipset vendors have their own proprietary techniques, but they call them proprietary, right? And it's there. It's there in the association frames. You can see it's there, and they are not cannibalizing on the standard solutions, right? You always can show you has a
right,
choice if you want to use the standard, I don't know, power saving, or do you want to use the vendor specific power saving? And of course, if the same vendor supports it, then you may choose the
right.
proprietary one, right? But the standard still works.
I wonder if that is because if we've talked about this on the show a bunch of times with a couple of different people about how Wi-Fi is a consumer technology first, right? I,
Because you don't want the piece of the user.
exactly.
Yes. Yeah. Yeah, in GPON you actually have two vendors, and those vendors can be don't they
Right.
can not like each other, but if the user doesn't like, doesn't,
Right. You can
then
piss them off.
exactly. I think that has a that's why.
Right? Because ultimately, they just want it to work and it does just work now, right?
Hmm.
But it never came from the top down. It was always the end user has always had control of that of their reality when it comes to consumer networking. It came from that side. It did not come from the other side at all. Even internet access didn't, because originally it wasn't operators, right? It was just a service that ran over the top over your phone line, and
Oh,
they didn't have anything to do with it, right, other than charging you for long distance calls if you happen to have to call to some other town, right, to connect to America Online or Prodigy or whatever, right.
I, I always like to tell a story about whenever I'm talking with my family or people who generally don't understand what internet is, right? Why was internet even created? Why was it designed like it is? There is one reason, right? Of course, U.S. military figured it out, and they wanted something that can withstand a nuclear apocalypse. Right? That's it. That's what the internet was
Oh, right,
designed
right,
for, right?
right. So decentralized, self-healing. Yeah, yeah, yeah.
Exactly. The routing protocols are meant for that. People don't appreciate it enough. It's
Right.
meant to
Wow, I
so
never thought of
cockroaches
that.
and the internet, two things that will survive nuclear apocalypse. That was at least the intention when they made it. Now it evolved to something a bit different, but I still
Right.
think
Well, what
this.
happened was they got pissed off that it's not centralized, and
Yes, yeah. So in a way, internet was like Wi-Fi nowadays. Sorry, but back then, right? So
yeah, yeah,
principle decentralized. Yeah, maybe that's why many people confuse Wi-Fi with internet.
yeah. No, it is because all of us experienced it as consumers for
Yeah.
since its beginning, right? So we didn't care. I mean, okay, now it's Wi-Fi. Now nothing has a plug anymore, so that's how you
Yeah,
connect to
nothing
the
has a
internet.
plug anymore. That's new for me. I don't have a plug in my laptop,
No.
and
Mine
I
actually did come with an Ethernet dongle, but that was unusual, right? I was like,
with a
oh, that's
dongle. They
cool.
gave you a
Yeah.
dongle.
Hmm.
Where is that dongle now?
It's in my bag. I actually grabbed it because I had to set up another router. And
Okay.
but that's the only reason it's in my bag right now.
Yeah. Some time ago, I actually had a real issue with a real customer that had problems with Apple TV devices, and the problem just went away when we took out the plug, the Ethernet plug. Just connected to Wi-Fi, everything's fine, right? And the problem proved to be something with DNS. I'm not sure, but the Apple TV devices, Apple, not just Chinese vendor, they were optimized and tested for Wi-Fi connectivity and not for internet
Right.
connectivity.
Right. Because everybody expected them to do that. And then when somebody
Yeah,
finally
that is the
didn't. Yeah.
primary use case for TV boxes. Come on, when did that happen?
Yeah. Yeah. That's crazy. That's interesting because, like, so, like, the only wired thing that I have in my house is the PlayStation. And it's only because it's sitting next to the router. Right. I wouldn't bother to, if it was somewhere else, I probably wouldn't bother. Um, and that's what we use for all our TV streaming, right? But even my teenager doesn't uses Wi-Fi for gaming, and she complains about it.
Yeah, I you know I'm a very specific in that case because some time ago, a few years ago, I just ditched my gaming PC. I just threw it away. It was old, and I didn't want to invest in new one.
Hmm.
And
It's a
I
constant arms race.
yes, and I subscribed to this GeForce Now service
Hmm.
on my Chromecast device, small
Oh,
Wi-Fi 5 device, and it didn't come with Ethernet adapter. This Chromecast device, so obviously I thought, oh, I will find an Ethernet adapter that works, and you can actually do that via USB-C. It worked fine. It was okay, but then at some point I just forgot to plug it in, and I haven't noted that it's fallback to Wi-Fi. And for like half a year, I did not experience any connectivity issue
wow.
by, by playing on GeForce Now Full HD streaming. That's like 50 megabit per second, a constant video stream, UDP, no retransmissions, and obviously video codecs have evolved a lot for this use case. But Wi-Fi is good enough for this use case nowadays.
Yeah.
Everybody's talking about Wi-Fi 7 that will unlock virtual reality use cases. That already happened like 5 years ago.
Yeah, yeah. And I
What
mean,
are we
people
even
talk about
talking
the
about?
latency problem a lot, but
Come
I've
on,
always
if,
often,
if you if you have half decent RRM with 5 gigahertz channel that is not abused by your neighbors, you won't have latency issues on Wi-Fi.
right. So when it comes to you guys and your design, when you're designing the products, and I assume you guys are obviously going into managed Wi-Fi solutions, or at least
Yep.
automatically managed Wi-Fi solutions, right? Is that the
Yes.
kind of things that you're adjusting for? Is
Oh,
basically
that's
everybody
my
else's
that's my
problems?
main bread and butter. That's
Yeah,
that's what I watch the most is the RRM. I need to be sure that we're always using the best channel, the best 5 gigahertz channel, because that's enough.
right,
That's really enough. If you want good user experience, then you have to be on a good channel. Period. Right?
right.
Obviously, you want to limit the number of channel changes because not all the stations play nicely. But at the end of the day, we do not really care for those stations that don't play nicely. We care for those stations that you're actually using for your daily video calls, for your daily audio calls, for your game streaming, if you will. Right? And those devices usually play nice. So if we can find a channel that is not abused by the neighbors, that in Europe we have this unique situation. Well, maybe you also have something similar that some 5 gigahertz channels allow for a much better range actually. So we try to prioritize those, and we DFS is a problem obviously on those. So a lot of the intelligence that we're optimizing is around that.
Right.
But no, if you, as I said, if you have a half decent solution to DFS and to automatic channel selection, Wi-Fi just works for any use case
Yeah.
imaginable.
Yeah.
even if it is video streaming with 50 megabits per second with extremely low latency requirements.
Right. And I was talking about this with um, Patrick on my last show, just about the speed with which the Wi-Fi standards are coming out, right? How it's like 6 and 6E were done, and then like 7 was only in a span of 2 years, and it's like, okay, you you can do that, but we're talking about like for the most part, not always, but for the most part, like hardware level changes like that are not going to be done in 2 years. Like, and you're just pumping this, and everybody's like, oh wait, now this one's going to solve everything, but we can already do a lot of it.
Yeah, Wi-Fi 5 is actually enough. That's my statement. And for all the use cases I can imagine for the next, I don't know, 2 3 years, it is enough. Of course, you can improve. You can always improve. If you want to sell a 10 gigabit internet subscription, then you have to go with Wi-Fi 7. That's kind of obvious because
Right, right.
because what ISPs wants when they're selling
But
their services is the speed test, the proof of
yeah,
service. You can't really do it on Ethernet
yeah,
anymore because nobody
no.
has Ethernet anymore, right? So you
But
need
that's so frustrating because it's so false.
it is, but then again, it has some value, right? If you actually can do, let's talk Wi-Fi 7. If you can do 5 gigabit per second throughput on 6 gigahertz, and then 3 gigabit per second on 5 gigahertz, and then maybe 500 on 2.4, then if you summarize that, then the capacity of real traffic that you can actually get from your router might be even easier with the MLO. It's
Yeah, yeah,
way above 5 gig, right? So you could do it, right? But find me a use case for residential
yeah, yeah. Right.
backup. I maybe
Although
download.
I didn't know that the streaming HD games, if 50 megs per use is that's getting up there. I used to, just talking about how like okay, a 4K video is like eight. So like unless literally you have 10 people in your house that are all watching stuff at the same time, and even if you do, you still don't need more than a couple
Well,
hundred
I
megabits per
recently
second.
upgraded my GeForce Now subscription to the Ultimate thing, and now I'm getting 4K streams with 120 FPS, and that goes to 75 megabit per second UDP
Uh,
stream.
Do you like it? Do you like because it's the streaming gaming stuff really like it hasn't caught on enough. Like Google canceled Stadia, right?
You're asking if I like it. I use it daily. I
Yeah,
don't have
yeah,
an alternative. I'm playing all my games on that, and it just works.
yeah.
Maybe because
That's
there is.
that's cool because there's been sort of a cultural thing about it not being very widely adopted because I guess people are worried about not owning their games or I don't know why. But
Well, with
it does
GeForce Now,
work,
you own
right?
your games. The only problem is that not all the games are available for streaming.
Mhm.
Like Sony game, for example. Recently,
Oh,
Sony
right.
released some games on PCs, but those can't be streamed on GeForce Now, and
Well,
many
because
other
they want people to subscribe to PlayStation now is
to
why.
their
Yeah, yeah.
because PlayStation Sony has their own streaming service. But you can stream those games just from
Mhm.
another service, right? It's like with Netflix or and HBO and I don't know Prime Video. You need to be subscribed to all
You know,
of them
look it up
together.
for every time, and it keeps changing because the licensing changes.
Yeah, so that is a bit frustrating. I grant you that. But if a game is there, I can actually play it. I don't play like competitively, but
Yeah,
I would win some games if I did because if you really think about it, the latency that is measured with for those services is often below 20 milliseconds. 20
yeah.
milliseconds, right? Your Bluetooth mouse has a bigger latency than that usually,
And that's literally real time.
right? I mean, I don't buy it. If you're losing because you're playing on Wi-Fi, it's because you're a bad player, Steen, right? It's not because of Wi-Fi. I had this argument.
I want everyone to hear that right now, especially Sky at home, my teenager.
Or maybe you have a crappy Wi-Fi. I don't know. But if you have a half decent Wi-Fi, then it's not Wi-Fi that is at fault. 20 milliseconds. That's my average
That's
latency
Are there
towards.
any? So two questions that I was thinking of. Are there any use cases that are probably going to need something better than that?
Then 20
I don't know.
milliseconds.
Yeah,
Uh, Virtual reality, remote racing with real cars. I don't know.
yeah, yeah. Right, right, right. Well, they were talking about how like it really messes with your brain if you have VR and there's too much latency, something like that, to the point where it's almost unhealthy or something
Yeah,
like
but
that. I
how
forget
much
what it
is
was.
too much? It's
Yeah,
like in
yeah,
the hundreds of milliseconds, right?
yeah, yeah. Right, right.
I'm not a huge
Um,
VR fan. I'm not sure. Maybe you need less than 10. In that case, you won't stream it via Ethernet either.
right, right. The internet itself doesn't have that level of latency, so
Yeah, I mean, good Wi-Fi is like maybe 3 milliseconds latency. Ethernet is less than one, right? So you're gaining 3 milliseconds. That's
yeah,
nothing.
right, right. Um, oh, the other question I had about, you know, what Wi-Fi is enough and where the gateways are going. The number of devices. So, like, is there any difference when somebody suddenly has 20 or 30 things versus two or three things, right?
Not really. No, no. That,
No.
that's a common misconception, right?
Yeah.
Obviously, there can be a difference, especially if the other devices are very active, and especially if they're uploading, because it's not centralized. And because if they're downloading, then it's easy because the access point can apply priorities and stuff like that. But if they're uploading, it's a bit more difficult. But nowadays, you have so much airtime that it's really difficult to saturate it so much that you can actually feel the impact if you have decent QoS, right? Mechanism and Wi-Fi has that if it's enabled by the content providers, and that's very important because most of the content providers do not implement any IP level priority tagging, and most of
Right.
our access points are actually looking at the IP level priority tags to apply that priority on Wi-Fi.
Right. 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 Right.
If they're not doing that, well, we really can't do anything about it. But if they are doing it, then it's easy to honor that. And I would say that for normal use cases, even if you're like downloading something, you would not feel like the latency impact, and not a lot. But if you have like bad players, slow old devices, then it starts to be a problem. If you have obviously a lot of retransmissions, that could be a problem. But retransmissions are usually tied with bad drivers, right? That
Right.
they're doing something wrong to not acknowledging packets
Right.
or
Right. Right.
stuff like that. It's not even about range because Wi-Fi is actually designed. That's one of the few things that Wi-Fi is designed for to work on different ranges, right? And dynamic ranges. We have
For
very
different
nice.
reasons. Right. Yeah. Yeah.
Exactly.
Yeah.
So I don't really think that you have any limitations on Wi-Fi that are real, that are
What
problematic.
are the problems? What are the problems that you see the most usually from the design and testing perspective? Like, no, without
Well,
revealing the problems. Oh, no, let me
everything,
clarify. Stuff
everything
that's
that
other
was,
people's fault.
yeah, it's always other people's fault. Come on.
Yeah.
Well, Apple,
Yeah.
it's like they often have their own view how the
The
protocols should
clients,
work.
right? Yeah.
Yeah,
Yeah.
the clients, but it's like small stuff like maybe compliance with 8211V or K or whatever that they're not always playing nicely there. Uh, but when it comes to like real problems like service breaking problems, it's those IoT devices on 2.4
Right.
gigahertz
Right. Right.
that can actually bring the entire network down. But they're only on 2.4 gigahertz. So who uses that for anything other than IoT? Come on. If you're using 2.4 for Wi-Fi, then it's on your own fault. Um, obviously, obviously, some people have like a single SSID
Right.
approach, and that works for most devices, for the devices that matter. But for some devices, it doesn't, right? And then a solution has to be found. So
Right.
it's if I am to name one thing that is causing problems on Wi-Fi, 2.4 gigahertz. That's what's causing problems on Wi-Fi.
Oh, well, we just have to forget about it.
Exactly. I mean, we have much better protocols for IoT nowadays.
Yeah. Right.
Thread. Why not?
Right. Right.
Why not just use that and disable the 2.4 radio? And of course, that means that you need to change some of your IoT equipment at home. But that's a sacrifice that I'm willing to
Right.
make. But I'm not sure about
Well,
other
and
people.
also it's now possible with remote management, that you can do that stuff on the fly rather than trying to expect the end users to do it, right? You can be like, okay, we're just gonna we're just gonna set up the network the way so that it works.
Oh, you would like to disable the 2.4 radio for users without them knowing?
Yeah.
Oh, that would be an interesting week.
Well, I mean, that's what it comes down to because I mean, Ecotera, you're selling mostly to operators, right? And so
Yes.
effectively, it's their service they're providing, right? It's not like a retail box necessarily. That was a
Mhm.
time in the past where that was way more common, but it's not now, right? So like what are the things that the operators are asking for when it comes to that, right? They want Wi-Fi to be good, but like what do they ask you guys to make,
Only the impossible, right?
Yeah.
And we deliver.
Moving the goalposts, right?
Right. But they don't think about that. Obviously, when it comes to operator requirements, it has to be easy for the end user. And easy for the end user
Right.
means a single SSID, right? It means that whatever worked in the past will work
Hmm.
after the
Hmm.
upgrade. So most of the users already have Wi-Fi set up at home, and if they're getting an upgraded router, they expect to not have to do anything about it. They just replace the router and it works. And many of our customers have ways to deal with it. But that means that we have to support old technologies like Wi-Fi was meant to support old technologies. The only thing I'm not saying we should remove 2.4 from Wi-Fi. We just should set right expectations. 2.4
Expectations,
is
right?
for IoT legacy devices, 20-year-old printers. For those use cases, 2.4 is great. Just
Hmm.
works, and the range is awesome.
Right. Oh yeah. Right. 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 Right.
Yeah, but if
We
you're doing anything else, if you're doing voice calls, audio calls, video streaming, then you can either use 5 gigahertz or 6 gigahertz. That's your options.
right.
Or
Right.
you can
Right.
do
Right.
analog.
Yeah. Which so and interesting enough, like even that actually in the grand scheme of things hasn't been around that long, right? The use of 5 gigahertz, right?
5
I
gigahertz.
mean,
I have a 20-year-old laptop that has Intel A adapter on. I still
really?
use it. Yes, it's an Intel
Wow.
Lenovo. So no, not Lenovo. It's Intel ThinkPad T60 something. They came with A adapter in. Extremely expensive. No, it's not 20 years old. It's 15 years old. I know because we got it when we started the company. We bought it then.
I guess that's the advantage of buying your computing equipment from the chipset manufacturer.
Uh, well, we bought it from IBM, so
Right.
it was just there. It was included. It was premium back then. 15 years
Mhm.
old Wi-Fi chip with A,
Right.
and it still works nice. You can still do a lot on A. I bet you can do video streaming on A.
I bet you could. I bet you could.
Maybe not 50 megs per second video streaming, but what we're doing right now, we could easily do on 802.11a.
Right. Right. Yeah. Yeah.
Yeah, it's
Well,
OFDMA.
that makes me happy.
Sorry, not FDMA, OFDM. OFDM, yeah.
Yes. Yeah. Which, interestingly enough, um, it's not an exact comparison, but the fundamental concepts of which came from DMT in DSL, right?
Oh, okay. I
Well,
honestly speaking, DSL is one thing in networking I know nothing about. So
well, the idea was an automatically adjusting um, a channel that's automatically adjusting to the noise environment, right? And based on its current conditions, and then uh, being able to do so over the worst environments imaginable, um, except for air, which
okay, from the very beginning at Icotera, what the one thing we said no to when our customers ask us for special features was, nope, we're not doing DSL for you. This is
Yeah,
that technology, and that was 15 years ago.
it lived its life. It's still out there, obviously.
Yeah, we still have customers that deal with it, and I don't know for what use cases, but we're discussing if Wi-Fi 5 is enough, right? But DSL is enough for many people, so
Yeah,
they
yeah.
don't have a problem with it. Well,
20
it's
you're
expensive, but
25 megabits per second, 25 megabits per second out to somewhere in the middle of nowhere. That's great. That's great.
exactly.
Yeah. You can watch 3 HD streams.
More than anybody would ever need to watch.
Right, right. Yeah. It's it's always interesting being on the front end of technology and also the back end of it at the same time, right? Because I would say that like our industry is cool because we're simultaneously the users and the makers of it,
Okay,
right?
yeah,
Which
that
which isn't often the case, right?
yeah, and maybe this is why I'm biased like that because I'm always working with the edge technology in my home. I'm always using like the beta hardware, beta software, because it's boring if I use the usual stuff. So it means that I have the best possible equipment in my home, and maybe that's why I think Wi-Fi is great. Not everybody
Well,
are
no, but it's
blessed
like
with
you
that.
said though. It's been working really well for a very long time. And even some of those older tech, even some of the legacy ones like G and before, like they they still work. Like they worked extremely well for what they were doing. So like,
Well, I'm not sure about G. Honestly, I would not go lower than N nowadays
mhm.
for other reasons, let's say, than spectrum management.
Right,
Uh,
but I mean, our experience of Wi-Fi, even when it was those things, was still pretty good. Like,
well, we started doing Wi-Fi. I mean, by we, I mean Icotera with AC actually. So from my point of view, everything before AC was bad.
is that like? I feel like that translates into other areas of life.
Yes, that's most likely the case. Yes,
And then far in the future, when we have Wi-Fi 12, we'll be like, AC was the best.
it was. I have to say that I have some feelings about N and really introduced a lot of nice stuff like special streams, like 40 megahertz radios. Obviously, it worked on 5 gigahertz, which is great. So I can appreciate N, but of course, AC, Wi-Fi 5, this is when it started really. No,
Cool. All right.
and
Well,
was when N was the revolution, right? So a couple of revolutions in Wi-Fi. N was the first
yeah.
one, and then it's introduction of 60 hertz is the second one, I would say.
So actually, that's a really good point because when I talk about how fast the spec has been evolving, how fast 802.11 is being evolving, you're right. There was sort of a big acceleration after N, right? Where it was like, okay, now we're going to do this and this and this and this and this and this and this and
Yeah, but it's actually Wi-Fi evolved from being very simple technology, I would dare to say, before N
Mhm.
to quite advanced when we actually took the multiple how do you call that multipath when we took the
Yeah,
multipath and changed it from being destructive to being constructive. That was the revolution that N introduced.
right.
And then for a long time, nothing that interesting happened in Wi-Fi. Then OFDMA was introduced in Wi-Fi 6. How did that work? Different opinions about OFDMA being revolutionary or not, right? Um, so now it's 6 gigahertz. So I still count two revolutions. It's with Wi-Fi 4, right? Wi-Fi N, and with
Oh,
introduction
yeah,
of
I
6
guess
gigahertz.
technically. Although they hadn't started doing that yet with the numbering until
Yes.
yeah.
Yes, it was a bit confusing for me this numbering at the beginning, but now it's difficult for me to change back.
Isn't
Wow.
that interesting? Good on the Wi-Fi Alliance for for jumping on that marketing train.
Yeah.
And it's worked. And it's like we said before, it's like then now that's something the consumer understands. Whether or not they care or not is one thing, but at least it's something they understand.
Better number
You know,
has to be better, right? You want the
yeah.
higher number. Buy the new router.
We- you should listen to the one I just did with Patrick. We talk a lot about that,
Okay.
which is funny because he sells routers too.
All right, then I will watch it.
All right. Well, thank you, Wojciech. I really appreciate this. I was excited for today. So, um,
Thank you.
this will be out next week.
Oh,
Um,
really? Oh,
yeah,
yo,
we're on the cutting edge. Uh,
we are. All right. I'm very excited.
and, yeah. All right. Thanks again, and we will talk soon. Maybe even in person at Broadband Forum or Purple or something like that. We didn't even get a chance to talk about Purple. We'll do it next time.
Yeah, I'm coming to Paris, so probably there.
Yeah, sounds good. All right. Thanks again, everybody. Please do, if you enjoy these conversations, subscribe to this YouTube channel, and that helps me let me know that you actually do like it. And or on your favorite podcast platform, which means you will get the next episode of this automatically. And above all, own the nerdy things you love and have fun doing them. Thank you.
Thank you.